Thank you all for joining us this evening. We'll be beginning at 6:30. For everyone that's just joined, thank you so much for joining us tonight. We'll be beginning around 6:30. Welcome everyone to the virtual education session. We'll be beginning in 5 minutes. Thank you so much for joining us tonight. For those of us who have just joined, welcome to the virtual education session on residential energy code training. We will be beginning in a few minutes here. Thank you all so much for tuning in on tonight's event.
I don't, I can. Oh, 1, 2.
Alrighty, without further ado, I think we'll go ahead and get started. Good evening, everyone. My name is Nina. I am the event coordinator for the Northwest Eco Building Guild. And welcome to tonight's virtual education session on residential energy code training. We might wait just a minute or two more. I am just letting in some participants uh, that are in the waiting room, the virtual waiting room, and then we'll get started.
Thank you.
Alrighty, we'll go ahead and get started. So welcome, everyone. Really excited for tonight's event. As of now, this event is being recorded. So please note that at the end of this event, a recording will be generated and that will be shared on the Guild's website. As folks are trickling in, please remember to mute your microphones during the presentation. There will be a question and answer session at the end of this event. And what I've created is a chat box. If you go at the bottom of your screen, you'll see the option for a chat. And there, please feel free to post all questions you have as the presenters are presenting. If you have any specific logistical questions or challenges, my email is right there. I can be reached at nina@ecobuilding.org, and I can try to help troubleshoot your issue you might be having. So we'd like to thank you to big thank you to our Guild supporters, King County Green Tools, Model Remodel, Small Planet Supply, Board and Vellum, Puget Sound Cooperative Credit Union, Northwest Partners, Alpin, Dunn Lumber, and Ole Fed. Thank you all so much for your continued support to make these virtual events happen in light of the coronavirus. And a huge thank you to our event-specific sponsor, Mighty Energy Solutions. So with more than 20 years of experience in home remodeling and a passion for green building, Mighty Energy Solutions finds the most efficient and low-cost technologies for your home. At Mighty Energy, they believe being comfortable in your space doesn't mean you have to sacrifice efficiency. Likewise, a super efficient home doesn't have to compromise on comfort. So they are consistently thrilled with their outcome of infrared radiant ceiling panels, particularly Ducoterra panels in remodeling projects. They offer a combined simplicity, comfort, and efficiency that is unparalleled by anything else in the market. Their infrared panels are absolutely awesome. And if you have any more questions about their insulated heat panels, you can contact them at info@mightyenergy.net. So thank you again so much, Mighty Energy Solutions, for sponsoring tonight's event. And then just a couple of upcoming events the Guild is putting on. May 28th, we'll have a carbon negative and non-toxic hemp and insulation webinar. That's tomorrow night to tune in on. June 24th is a virtual education session, another monthly education meetup. It's a solar DIY education presentation. And then on August 20th, we'll be having a symposium series of future-proofing multi-unit buildings. Thank you so much for joining. And without further ado, I'll go ahead and introduce everyone to our speakers. Tonight we have Michael Lubliner, a senior building scientist who has worked in the energy conservation and renewable energy field for nearly 40 years. In 1983, Michael began working for the Washington State Energy Office, which later became the Wazoo Energy Program, where he helped develop, implement, evaluate, and refine the Northwest Power Planning Council's model conservation standards, state energy codes, and super good sense site-built and manufactured housing programs. He leads the Washington State Energy Code Residential Technical Assistance Program and also supports the U.S. Department of Energy's Building America program and the U.S. Environmental Protection Agency's Energy Star program. With him tonight is Melinda Spencer. That'll help with his presentation. And Melinda is the Education and Outreach Specialist for the residential sections of the Washington State Energy Code and for Washington's Renewable Energy Incentive Programs. Emphasizing plain language and user-centered design, Spencer has decades of experience as an instructional designer, web content developer, webmaster, technical writer, and editor, and risk communication specialist at Superfund sites. She holds a BS in biology, pre-med from the University of California, Davis, an MA in technical and scientific communications from Miami University, Ohio, and an MPhil in International Peace Studies from Trinity College, Dublin, Ireland. So thank you all so much. Michael and Melinda, I will give you the floor. I'll go ahead and stop sharing. And again, for those who have just joined us, this event is being recorded. And if you have any questions during the event, please post them in the chat. In addition, if you could please keep your mic on mute, that would be great. Allows our speakers to present without any background noise. And welcome. Thank you again to our sponsor, Mighty Energy Solutions. And with that, Melinda and Michael, I am going to go ahead and give you the floor. Alrighty. Melinda or Michael, are you guys on? Melinda, I have just stopped sharing, so I think you can. Yeah.
Can you hear me now?
Yes, we can hear you, Michael. Thanks.
There's a little delay on the time you went to unmute me to the time I actually got unmuted, about 5 seconds, it seems like. Okay, great. Gotcha. Thanks. I was a little worried. So I'm calling in on my phone, and I think Melinda has the screen. So we can get going. I want to thank everyone for giving us the opportunity today to share kind of where we're going with a pretty exciting residential energy code, one of the more aggressive and progressive in the United States for residential buildings. That includes the scope, and I'll get into a discussion in the code. The goal today is to give you a little overview about me and how I got here and how what I've been doing for the last 40 years relates to the energy code of today. Then we're going to have Melinda give us a little tour of our current website. I would encourage everyone to do some penance on our website if you really are interested in becoming an energy code expert. It takes a few hours of time and commitment, and then be sure to contact us on our website with questions that come up as you spend that time there. Anyway, I wanted to let everybody know we'll do a little introduction, then a tour, and then we're going to demonstrate a beta test version of the new prescriptive path tool and give an example. This is something that should be available in the next couple weeks on our website in preparation for the new state energy code that will be coming in November. It was to have been coming in July 1st, but the delay was occurred as associated with the virus, and the slowdown in the construction implementation. So today the focus is going to be on the new code and the changes from the old code. And then we'll actually go through a pre-recorded 1-hour presentation that I did on the code, and then we're going to answer questions. So we have the opportunity to answer live questions after the presentation, and then also if your question doesn't get answered or we need to take it out into the parking lot and work on it a little bit more, we can communicate and resolve our questions and via our email, and we'll show you how to contact us on our email site. So a little bit about me. I want to thanks for the introduction. So I've been really blessed in being able to be what we'll call an energy bozo, doing research and demonstration of concepts, bringing it all the way to pre-market commercialization of emerging energy-efficient technologies, trying them out in voluntary utility programs, both in the research context or in laboratories, either in field labs or with the national labs, looking at different emerging technologies. From there, the RD&D goes into, is it cost effective? Is it something that belongs in an energy code in the Northwest? And that's kind of what I've been working on. I started my career in 1978, graduated from Evergreen Energy Systems program, worked on solar hot water, developing thermosiphon appropriate technology water heaters, composting toilets built and monitored, and methane digesters, and all that kind of groovy stuff in the 70s. I was very impressed by Jimmy Carter's war to be more efficient on energy and energy waste, and I got involved in the solar industry. In 1980, I was the distributor for Grumman and Novan solar hot water products, mostly water heating, bioenergy, radiant floor heating, and swimming pool heating products. And I worked in the private sector for quite a few years doing training and design in renewable thermal energy systems. Then Reagan came in and we got rid of the energy tax credits, and I went to work for the government. No, just kidding. Actually, I did. I went to work for the Washington State Energy Office in 1983, and I was, again, blessed to be able to start working on what they call the Northwest Power Planning Act. And this was an act that was created in the Northwest after the Washington Public Power Supply System debacle of building way too many nuclear power plants and not needing the power immediately for them, that we decided in the Northwest Power Planning Act decided that if we could show that energy conservation or renewables are cheaper than building new power plants, then let's look at implementing them. And one effective way of implementing energy conservation that's cost effective is through energy codes. So I started in about 1983 doing research with Bonneville Power Administration, the utilities, and we built hundreds of homes and monitored them, studied them based on the model conservation standards. Well, it's funny, that was 40 years ago. We were looking at a target of an inch of foam and a 2x6 wall and an air-to-air heat exchanger at a house at 2 ACH 50, pretty tight house. And that's kind of where we're getting to now in the new code. So it's been a long, strange trip. We've made some real progress in mechanical equipment, and I'll talk about that today. Come 1986, we kind of vetted these utility programs to determine whether or not the model conservation measures were cost-effective for an energy code, and we adopted the 1986 Washington State Energy Code. That had about a 7 air change an hour air leakage factor, R19 in the walls, R30 in the vented crawl space, and an R38 in the lid, and a reasonable low-E vinyl window that was available at the time. And that's kind of where we're at in 1986. Sometime in the early 90s, I moved over to the Washington State University Energy Program when the Energy Office was discontinued. And I continued to work on a program called the Super Good Sense Program, a voluntary utility incentive program to kind of, again, vet some of these new technologies in building systems. I was fortunate to work on Super Good Sense and Energy Star and work with a bunch of energy folks around the region. Many of you, I hope, are on the call today and want to say hello to all you folks. I've also been doing things since then in the R&D model. I've been working with the ASHRAE 62 committee which focuses on residential ventilation and indoor air quality. And recently, I put an article in about ASHRAE Journal on the challenges of maintenance and operation and commissioning of residential ventilation equipment. And I'm happy to report that the new code in our state is going to require that somebody commission the ventilation system and write the numbers down on the compliance certificate. We'll talk about that a little bit today. But some of that comes from ASHRAE 62.2 and other sources through the State Building Code Council process. I'm also a member of ASHRAE 90.2, which is a REACH code that inspires to be 50% beyond the IECC codes, and it's actually similar to the energy code we have in our state now. The only difference is that we don't have an ERI, an energy rating index, like 90.2 does, or the home energy rating standards do. So I'm doing quite a bit of work with ASHRAE. I'm the subcommittee chair of 90.2, working on the mechanical. The big thing there is moving the ducts into the conditioned space, and I'm going to talk a lot about that today, the low-hanging fruit in the energy code. Then I've been working with the U.S. Department of Energy's Building America program and the national laboratories in research and development for many years. Two examples are working with Habitat for Humanity, Quadrant Corporation, New Tradition Homes, and a broad diversity of stakeholders with some utilities on showing that it's cost-effective to move thermal distribution system and central forced air systems into the conditioned space, which is now a big chunk of what's going to happen and challenge us in this new code. The other one is working on ventilation controls, smart ventilation controls that help to reduce the uncertainty on maintenance, operation, and commissioning, and help to improve the performance of those. So I'm working on some, besides doing the Energy Code hotline and stuff, I'm also doing research with DOE in these areas. And as we develop those, we hope that there will be opportunities to enhance the code. I also do work with Labor and Industries, Factory Assembled Structures Advisory Committee. That's a board that advises L&I on housing issues related to things that are built in factories where L&I regulates. And one area that we're involved in is tiny homes that are built in factories, modular homes, and HUD code homes, mobile homes that are regulated by the federal government. So I've been doing that for about 30 years as well. And in addition, I'm now currently, and since July of 2018, been running the Washington State Code Technical Assistance Program. So that involves trainings like these, updating new materials to reflect the new code changes, a whole bunch of participation on energy, building code council meetings and things. So that's kind of where I'm at, and I hope that was useful in understanding kind of what I do, and where you can always feel free to use me as a resource if you have questions related to the broader building science concepts. I like to think of myself as someone that takes a systems engineering approach to energy efficiency, indoor air quality, comfort, health and safety, and durability. And I know that's big values of the Eco Building Guild. So again, thank you today for giving me the opportunity to share with you information on the code. And I'd like this to be a two-way street. I'd like to learn as much from these presentations as I share. And I'd like to stay focused on the technical side of the code and not the policy side, because that can sidetrack us really fast. Having said that, I think we're ready to go maybe have Melinda take control and give us a tour. I will talk and she will drive, and we'll tour the Energy Code website as it is. We are in the process of designing changes to the website, so there'll be significant changes this summer that will come around that will allow us to transition to the new code while retaining some of the old code information on the website. So let's see where we go from here. So if everybody sees, this is our domain, the Energy Code website. What we have is notices that have come up here. The first notice was the delay in the code. On the left side, you can link to other programs that our office is involved in. We do green transportation, we do renewable energy incentive program, and Melinda has been a main gear, my associate Melinda Spencer here has been a main gear on the PV program as well. If you need information on the Energy Code, you have questions, there's broader than just this energy web page here on this Energy Code site. You can download information on the worksheets and get useful text information on the code. You want to make sure that when you contact us, that you start with, Melinda, can you just scroll up one little bit? I want to show the contact. There it is. So when you have questions, call and you click on that energy code at energy.wsu.edu. It goes right to Melinda and I, or Carolyn Roos, our other technical engineer here, and we can answer your questions. The more information we have on the questions, and that includes questions that come from the presentation today, the more information you provide, the better we're able to efficiently answer the questions. So if you need to get hold of us, that's how to click on. Or you can call us at 360-956-2042 and talk to a live person. We generally try to get back to folks within 24 hours. That's kind of how to get hold of us if you have code questions. The next thing is if you're doing non-residential energy code work, then there's a link to Lisa Rosno and the folks that do the non-energy code technical assistance at the Evergreen Technology Consulting. We try to work directly with them. If you run into a project that's mixed use, in other words, there is some commercial and some residential, you'll need to work with both. I'd recommend always starting with the commercial folks. They are a little more challenging processes. Okay, the next thing we have is the worksheets, and this is what we're going to be updating. But virtually, the large majority of the people work with the prescriptive path worksheets. This is a cookbook recipe that we use, and we'll explain it in the presentation. That basically, you know, you take one from column A, one from column B, and this is the prescription of insulation levels, air tightness, and equipment, and that will guide the majority of folks' compliance. There's a couple other approaches for doing compliance that we'll touch on, but these are the ones that, like I say, the vast majority of the people use, and if for some reason you can't use this system and you want to use one of the alternatives, then we always recommend doing more investigation on our website and then calling us if you have questions. There's 2 alternative compliance paths and worksheets for that. But the more important ones is the prescriptive path. You have to download the worksheet, and then there's the energy credits associated with the worksheet. And those have to do with how big the home is or what kind of project it is and how many additional credits you need to build to. And then there's a very important PDF called the Prescriptive Energy Checklist. And again, we'll be updating these documents. But this is for people as an internal document with their subs and to make sure that they've done all of the important details, mandatory details in the energy code. So if you're working in the energy code, become an expert on the prescriptive method, understand how the worksheet works, what your options are, understand the energy credits in Table 406, and understand the requirements and the checklist on site for quality assurance to help you stay in unison with your subs and with your building departments. The more you invest up front in this stuff, the less hassles and headaches you have after the fact in conflict management. This is especially true for do-it-yourselfers or people that aren't really familiar with building science. I always tell folks, spend an hour or 2 on our website and you'll save a lot of money in the future. So some other things as we scroll down is some combinations of credits that we'll be updating that'll show you how to get to the energy code at what we believe is the lowest cost approach. There's a number of approaches to get there, and we'll talk about that today. There's also the glazing schedule worksheet. That's a worksheet that allows you to do, you put your window and door schedule into it, put in the tested U factors, and it'll help compute what the average U factor is for the energy code qualifications. Some building jurisdictions like to see this as part of the window schedule. Some just want to see it reflected on the plans. Then we have what we call the heating system sizing worksheet. And, you know, quite often you go in to provide a plan and you don't have a heating contractor yet that could help you on sizing the equipment. This is kind of a tool that we have, a worksheet as a placeholder. It's for new construction only. It doesn't do retrofit and it doesn't do air conditioning, but it does give you some idea of how big the overall design load for the heating system needs to be. And that's if you don't work with a heating contractor, you might need to familiarize yourself with how to use this when you go in to submit a plan. We always recommend, once you've selected the heating contractor, to have them do a load calculation that may involve room-to-room calculations as well as other air conditioning evaluations that are much more sophisticated and within the skill set of a heating contractor. So even though we have this heating sizing worksheet, it's not the end-all, and the code does require additional analysis to be done, typically with software tools like ACA Manual J or equivalent tools. Then we have some what they call the UA worksheet. This is what I was referring to as an alternative to the prescriptive approach. It's a little trickier to comply with when you have a large amount of glass, over 15% for the wall area. It gets tricky. If you need assistance, some people will use this when they can't use the simplified approach. And I think we're going to get more and more people using some aspects of this for compliance with the energy credits, and stay tuned on that. There's also the alterations remodeling worksheet. So we get a lot of technical assistance calls on remodels and alterations. And there's a difference between the two. We'll probably be doing a separate webinar on that. But basically, the big difference is if you're just remodeling existing permitted conditioned space, heated space, then it's called a remodel, and you don't need to meet the full energy code. If you are adding new conditioned space, either converting a garage or a basement or building up on an attic, then you have to meet the addition needs to meet the full energy code. And we have in there you would use the prescriptive worksheet to do the addition, and for remodels, you would use the remodeling worksheet. So if you're just doing a standard remodel and you're not adding any square footage, there's the worksheet to use. It's very straight ahead. Basically says if you open it up, you need to bring it up to code. If you're not opening up or changing it out, then you don't have to bring it up to code. Then we have some very interesting resources. We have copies of the residential and the commercial text, along with the appendices, which gets into the heat loss equations and the assumptions for all our assemblies. And then we also have compliance tools, a variety of tools we have that I'll talk about, affidavits for new construction and existing construction, for blower door tests, for duct leakage tests, a lot of tools here to become familiar with, air leakage tests, and then what they call the certificate, which we'll talk about. That's the thing that you fill out and put on your breaker panel or close to your breaker panel. It's permanently affixed to the home. It provides everybody information on how much insulation's there, what kind of equipment's there, what are the energy compliance paths, and we'll talk about the certificate. We are going to be updating the certificate as well. As I mentioned, it's going to require not just duct leakage testing and blower door testing, but it's going to require commissioning of ventilation systems and the ability to document that you've actually done the test by providing GPS and time series potential documentation of your blower door tests. The reason we do that is we're starting to hear that there were some folks out there cheating on this stuff. So we're going to make it a little harder for those that cheat, what we call the out-and-out liars, to compete with people that are trying to do the right thing. And it's not a large amount, but you'll see on the new certificate there's some questions about can I provide a GPS and timestamp verification if asked by the building department. There's a variety of tools there. I'm not going to go too far into it. Then we have the scheduled trainings. So we're going to be setting up trainings where, like this, a training where you sit down and watch a video, and then and we'll be live to answer questions. And so stay tuned to that. Make sure you sign up on our mailing list. Send us an email and get us on. And if you get on the mailing list, then as trainings happen, you'll hear about them. Then we also work with our Beyond Codes program, and we also work with a group in our codes program of heating contractors. Let me start with that, the list of duct testers. In the energy code, we have a requirement that if you have to test the ductwork of HVAC equipment, and those that do the tests need to have taken a class from us and gotten certified. So this is where a builder or building official would go to see who's taken the class and if they've been certified. And so if people are interested in taking that class, send us an email, and we're building a mailing list. It's a class that it doesn't teach you how to do a duct leakage test. It teaches you what the requirements are for our state code for doing it, a little bit about the first principles and the technical details, but it doesn't teach you how to use the equipment. It is the beginning of then going and working with either the Energy Conservatory or Retrotech, manufacturers of the equipment, and taking their training classes to learn how to use their particular equipment. But it's an important point if, to the extent that you have thermal distribution systems like ductwork outside the conditioned space, that you need to test to make sure they're not too leaky. You know, a leaky duct system outside the conditioned space on a $5,000 to $10,000 expensive heat pump is like buying a Tesla and driving it on flat tires. And you'll hear that a couple times. But that's the bottom line. If we're going to get serious about energy conservation, we need to make sure that we get to moving the ductwork and the thermal distribution systems inside or not use that type of distribution system. All right, I'm kind of rambling. Last but not least, we have some links to our home energy raters. I imagine there might be some home energy raters on the call that are Eco Building Guild members. We do Beyond Code programs, and Rob Penny and Jonathan Jones in our office can link you into those programs. And then we have a variety of webinars and videos that we encourage folks, everybody from a customer you might have that wants to know why am I tightening up the house and then putting a fan in it, on build tight, ventilate right, to healthier indoor air quality, healthier home, to why do we test ductwork. So I would encourage everybody to spend an hour watching these videos. I think we're getting down to the bottom of the page. We have some presentations that we'll be updating. And then there's some hot topic archives that we'll also be updating. But again, if you have some time, the most important one there is that ACEEE ducts inside. That's research that I alluded to that we did with DOE and Building America. This is all the tricks for how do you move the ducts into the conditioned space, or at least some of them that we've used. That's a critical one. There's a whole bunch of other interesting technical information there. So that's the hot topic stuff, and that's pretty much a quick tour of our existing web page. All right. I think at this point, if we do have questions, let's hold them for the end, and I think if it's appropriate, we should go start and open up the, Melinda, you're going to open up the worksheet, and we can show what the new worksheet looks like? Uh-oh, I see a Mr. Wildenhouse in the house, and a Mike Steffen, and a, it's going to be a tough crowd. Okay, I want to thank, I see Dan's in the audience. We've been beta testing this new worksheet. Okay, this is the, this is the certificate. This is what I was talking about, the new certificate. I'm going to start in the upper corner. This is basically the information associated with in the upper left corner is the information that's on the existing certificate already since 2015, information about the house, the conditioned floor area, the R values of all the information from the code, what U factors were used for the averaging of the windows, what kind of heating system you're going to be using that will come into play. Then there's the heating and cooling and domestic hot water type. You need to provide the information here for the energy credits. If there's on-site renewable energy, you need to fill out the information about that below. And then if you're taking credits on appliances and things, you need to provide information on the appliance make and model number, whether it's Energy Star. That's pretty typical stuff. And then on the right side is the second part of the form. This is where we get into the duct leakage testing. All duct work and air handlers in conditioned space, yes, no. All ductwork in conditioned space or buried and tested, such as air handlers. So we're trying to establish what credits we're taking on where the distribution system is. And you can get some credit if you bury the ducts but locate the air handler inside, and you could get even more credit if you put it all inside. Then if you don't put it inside, you have to test it. And then it's asking for what the test results are and whether or not you have can verify that with independent timestamp and location verification. So that's what the duct leakage testing is all about. Then below it is a similar thing, but it's the building leakage. What is the blower-door design, and how close to the design did you hit when you did the test? So one is the target, and one is what you achieved, and those both have to be written down, and again, documented that you can furnish proof that this is a real test. Now, the big area of improvement is going to be in whole house ventilation system measured flow rates. And this is taken right out of the new Washington modification of the mechanical codes in the IRC. And it really pertains to single family, this part of it. So what we want to know is what kind of whole house, well, first, the most important thing, and I can tell you from 40 years of research, the next two questions are the most important thing in building science. They say, are the controls correctly labeled? We're talking about the ventilation controls. Is the whole house ventilation system operation and maintenance instructions provided to the building owner? Provided to on what date? If you do this and we build tight, then we can do our responsibility and due diligence to ventilate right. And this is kind of where it's really important that we take and pay attention that it's not just putting the equipment in or designing it, it's teaching people how to install it, how to commission it, how to maintain it, operate it, and what was the intent of it in the first place. So that's important, and then once you've then labeled the controls and explained the occupant procedures, then you can decide what kind of system it is. Is it a whole house system operating continuously? Where is it located? If it's a whole house exhaust system operating intermittently, how many hours is it designed to run for to be in compliance? If it's an HRV or an ERV, the same questions. What's the run time if it's designed to be running not continuously? And then if it's an integrated system that uses the furnace fan in integration with a supply fan or other exhaust fans, you need to specify a sequence of operations and provide it. We have found in the past that people that try to integrate into controls of central systems, it's very difficult for anybody else to evaluate what they've done and even troubleshoot it or even define if it's in compliance or not. So if you're going to be using a furnace integrated system, you'll probably need to provide some of the manufacturer's control logics. But that's kind of the expansion of what we've asked for on the ventilation, and then we basically ask, what was the design ventilation rate, and what did you measure, and what did you commission to? And then we ask, we have an exhaust, if there's a heat exchanger, they want a requirement that it be within the balanced. I think that's probably really helpful thinking that we're going to be within 10%, but that's the target goal. And then you want to make sure that the equipment, the Energy Star equipment is properly certified. So there is going to be an additional challenge here in teaching people how to commission equipment so that we're ventilating right when we build tight, and how to fill out these certificates. So this is something to stay tuned for. We have instructions on how to fill out this form that are going to be out and posted to help you along, and then we're likely to have a webinar on it. But this is where the rubber hits the road on commissioning. And I think it's going to be a challenging but an important part of a good sustainable project or code. All right, thanks, Melinda. Do we want to quickly show the worksheet? We want to try the single family worksheet. There it is. Thank you, Melinda. So kudos go out to my team. This is a works in progress, but many of you are familiar with the existing prescriptive path, which worked for both single family and multifamily R2. We have an independent one for single and multi on the new, because there are different credits for both in the new code. So I'm going to show you an example of the single-family one right here. And this is going to get rolled out as a beta test in the next few weeks, and then we want people to kick the tires and try to crash it, make it work so that we're ready with all the bugs and everything out of it come showtime in November or earlier. We're hoping to have it all ready and operational this summer. But the first thing you would do is understand that these apply to IRC, 1 and 2 family dwellings, and townhouses. So you put the project information in other words, where the project is and all the details for permitting, and then who is the one taking the permit, the legal person. Then you go ahead and that's the legal person signs off that these are the requirements for the energy credits, and then you go in, and what it does is it has the actual prescriptive path that you need to build to, and these are the insulation levels that would be on the plan. You want to scroll down, Melinda? And then a little delay here. There you go. So yeah, so now you're down on the page where we actually start to do the calculations. And the way this works is that, as I said before, you select the size of the home, determine the number of energy credits. Small credits, you need 3. Medium credits, you need 6. Large units, the large McMansions, you need 7 credits. In additions, less than 500 square feet need 3.5. So you go through, and we're going to just do a quick example. We're going to take a home with say a heat pump. We're going to take a heat pump in the main living area of the home, right there. All right, so that's a central heat pump, and that's going to get us what we call these fuel energy credits. And I talk a little bit about that in the video. Basically, this is a carbon equalization credit. What it means is that if you're going to build with natural gas or electric resistance, you have to build more efficiency into the home. If you build with a heat pump, then you get some credit towards that. So we're going to assume this is an all-electric home with a central heat pump, and then we're going to go in and look at the different energy options. So the first pack is the options in column 1, and those options have to do with the building envelope. And I think if you look at option 1.1, let's click on that one. And if you click on that one, that'll give you a half a credit. And what that is that's like going to an R38 in the floor and getting to about a 2.8 window. It's a little bit better shell. Now let's see if we go down to the section 2 energy options. Those are the build, tight, ventilate, right options. A lot of people take that 2.1. That's basically testing the building down at 3 air changes an hour and putting in an Energy Star exhaust fan that's energy efficient. So let's start with that one. So now let's go down to the 3s. The 3s are the HVAC system. So in this case, you could take the high efficiency HVAC system 3.1, that would be the heat pump, and it has a little bit higher HSPF than is required. Well, let's see, you want to take 3.2, let's check. 3.1 if the heat pump, yep, 3.2, excuse me. Yeah. So then if you go down to, say, hot water on the next page, and then, oh, I'm sorry, then we want to move all the ductwork into the conditioned space and get a credit for that under 4.2. So click on 4.2. Now, if you scroll down all the way, you're at 4, and you need to get to 5. If you put in a heat pump water heater, and say you wanted the one that's the tier 3, that's probably a 1.5, that's 5.4. If you go with 5.4 credit, now you're, yeah.
Hey, Mike, sorry to interrupt. Can you make your screen bigger? You've got a lot of white space and the letters are practically invisible.
Oh, thank you. Melinda, can you do that? Oh, yeah, much better. So here you'd be at 5.5. You need 6. You need to come up with another half a credit. So you can do this by going to a more efficient heat pump water heater. If you went to the tier 3, that would get you 2 credits, and hit that, and bingo, you're there. So let's just recoup. You got 5.5. That's a heat pump water heater. Why don't you scroll back up, Melinda? We're going to, whoop, too far. We're going to move all the ducts into the conditioned space, get a credit for that as 4.2. We're going to get a credit for a high efficiency heat pump, and we're going to get a credit for, scroll up. No, I'm sorry, go back up. Sorry about that. And we're going to get a credit for a little bit more efficient building envelope that's built tight and ventilated right. And that's how we would get one option towards getting the 6 credits. And this is just a little show and tell of the form that's going to be fleshed out. And there's a whole bunch of other options. I think a lot of the Eco Building Guild members that are more focused on envelope to comply are going to get very innovative, and we'd like to see what you got in the way of coming up with ways of meeting the envelope requirements. There's also some options, Melinda, if you scroll down a little bit more, for renewables and appliances. And we'll talk about that a little bit in the presentation. So I apologize, I couldn't see a lot of that, but this is just kind of a quick show and tell. So now what I'd like to do is see if we could go to the actual recorded presentation that's been on the website for a few weeks now. I want to apologize on the quality of it. I was getting over a really bad cold. Hopefully, well, it wasn't as bad as it could have been. So I'm a little bit of coughing in the presentation, but I think it's a good hour. It's chock full of information, maybe too much information. So I do ask you all to put up with my ramblings and keep good notes so that afterwards, tonight, we can get them as many answered as possible, and those that we can't, we can follow up with emails and follow-up coordinational calls on the hotline. Thank you very much. Melinda, or any other things before we get into this that, Nina, do we need to know?
I think we are good, Michael. Thank you so much. Thank you so much, Melinda, for sharing that your screen. I can go ahead and share now the pre-recorded presentation, Michael, if you're ready to go.
I'm ready. Thank you.
Okay, sounds good. Just one moment, please, and I'll get that up and running. Alrighty.
Hi, my name is Mike Lubliner, and I work for the Washington State University Energy Code Hotline. We handle energy code questions on the new energy code. This is the 2018 residential code, which will become effective July 1st, 2020. I'm going to go through a presentation with some of the critical information you need to know about the changes to the energy code. If you have any questions, feel free, after participating in the webinar, to send us via email or phone any questions you have on this presentation or any other questions on the current energy code, the 2015, or the new energy code, the 2019. A little bit about us. We provide technical support in Washington State on the energy code. We provide training in person, webinars like today, and recorded webinars and videos that clients can use to learn a little bit more about the various important aspects of the energy code and general building science information. We do phone and email inquiries, and we also develop energy compliance tools. Stay tuned. We're in the process now of updating our compliance tools. We hope to have those tools ready in May so that you will be able to use those tools in planning for the new energy code. We would encourage you all to go to our website and spend some quality time understanding some of the important information there. The kind of services we deliver include training. We had over 80 trainings on the 2015 code up to last year. We have about 2,000 folks attending. And we get over 2,000 hotline calls and emails annually as well from folks that have questions on the energy code. We also participate in the development of the energy codes, like the new one, by participating with the State Building Code Council in the Energy and Mechanical TAGs. That stands for Technical Advisory Groups. If you're interested in being part of the energy code process, you need to contact the State Building Code Council. This is our domain. This is our website. Again, I would encourage you to spend quite a bit of time here if you want to come up to speed on the code and general building science. We are the residential code folks. If you call the 956 number, you will get either myself or my assistant. You can also email us.
Oh, so I can put Beanie in her crate?
The non-residential is not a code that we handle in office, but we have linked to Lisa, who can answer your questions on the commercial non-residential energy code. Why are we here? The history of the energy code is important to understand as we move forward. The 2018 code is getting us about 45% of the energy savings as where the codes were at in 2006, or about 15%. The chart here shows you from 2006 to 2018 the reduction in energy use for typical prototype homes that have been assessed in the energy code program. As you see, we're trying to get down to roughly 70% savings or 30% of the energy use by 2030. That is the goal, state legislative goal, and is a law. Hence, we need to constantly improve on the energy code. The challenge is that as we get lower opportunity, as we have less opportunities to find cost-effective measures, or in other words, the low-hanging fruit isn't there anymore. This really is going to challenge us, and I'm going to present some of the solutions for meeting today's energy code and the future energy codes that will be coming by finding a balance between mechanical HVAC, water heating, thermal envelopes, and renewables. And the energy code will provide some flexibility towards meeting those goals. The code is broken out into 6 chapters: scope and administration, definitions, general requirements, residential energy efficiency. That's a big one to review. And if you're involved with additions, existing buildings, change of use, it's critical that you understand Chapter 5. In addition to that, we have our reference standards, and that's just pretty standard boilerplate. We do have Appendices A, which is there to help guide you if you have heat loss questions as you develop your U factors for your assemblies. If you're using non-conforming types of assemblies with different types of products that aren't necessarily part of our prescriptive compliance approach, you'll need to refer to the Appendix A for equivalent U factors. I'll get into that a little bit more. There's some other appendices as well required associated with modeling, software, and the weather stations. Really, Chapter 4 is where the meat and potatoes is in terms of understanding how to meet the energy code. Section 401 is general. Section 402 gets into the building envelopes. Section 403 is mechanical systems, water heating, HVAC, etc. 404 is electric power and lighting systems. 405 is if one was inclined to do a software compliance using the simulated performance alternative. 405 describes what the software needs to meet to be acceptable and what are the assumptions in the modeling. Very few people to date are using simulated performance alternatives, and I'm not going to get into too much of that in the presentation today. What I am going to spend today on is talking about R406. This is the critical and most innovative and challenging portion of the energy code. This is getting the additional energy credits besides building to the building envelope prescriptive requirements necessary to meet the new code. In addition, the new code has a compliance path for those that are certified passive house builders. I will not be talking about that today. If you're interested in passive house, I would encourage you to go to the passive house organizations and learn more about their information. In the future, we will have links to information on passive house and other useful information on how to meet the energy credits. Stay tuned. So let's talk about how to comply with the energy code. First and most common way is R402.1, the prescriptive approach, and then using the energy credits in Table 406. The second approach, which I'll touch on but not do too much discussion today, is a UA alternative approach. That's a trade-off approach where, say, one wants to use a less efficient window package, but it's going to make up with it with additional insulation in the floor, roof, ceiling. It's a thermal envelopes trade-off. It's used quite often in other codes around the country, like the IECC, and we don't see much use of it. If it is going to be used, it needs to also be used with the additional energy credits in R406. As I said, simulated performance alternative with energy credits is an option, very rarely used because we don't have a lot of software that meets the requirements for our code in using this compliance approach. In addition, the most important thing in the new code is to understand very clearly what the requirements are in the energy credits for both single family and low-rise multifamily. The credits have increased significantly. The single-family credits increased based on the size of the home. Multifamily tripled, as did additions. We will talk about that today. And as I noted before, there's a path for certified passive house. While there are folks using simulated performance analysis, what they call an ERI or a HERS score, that's kind of an energy rating index that is used quite often for building beyond the energy code and getting utility incentives in our state by energy raters who we have trained or others have trained. You can find more information out on energy rating and raters on our website. One of the cool things about working with an energy rater these days and getting an energy rating index, even though it doesn't meet our code, is that it's very close to many builders who building under our code may be qualified or very close to achieving a $2,000 per home builder tax credit. I'm not going to talk about that today, but if you're interested in energy tax credits as a builder, please look to our raters and they can help you with that. Okay, that's the general overview of the code and the compliance approaches. Now let's get into the nitty-gritty. I said this is the cookbook, prescriptive R values. What we mean here in table 402.1.1 is fenestration. That's a fancy name for glazing. So you need to use an average weighted U factor of all your fenestration products that comes in below 0.30 or 30. This is typically a vinyl double pane low E window. Skylights, the maximum U factor for the prescriptive path is 0.50 on a weighted average. Ceiling U factors prescriptively for a vaulted vented attic are 49. If you get into a rafter, unvented rafter space, you're allowed R38. However, you're going to have to meet some certain criteria on moisture retarders and things in the International Residential Code associated with vapor retarders. In any event, ceilings are 49 in a vented attic, R38 in a vault. Wood frame walls are R21. Intermediary framing is basically an insulated header of R10, and attention to detail on how many sticks you put in the wall. R30 is the prescriptive requirement for a vented crawl space. The insulation in the floor would need to be R30 or greater. And if you're building below grade, you have an option of putting R10 on the exterior, R15 or R21 on the interior, and a combination of approaches if you're finishing out the basement as part of the permit. If you're building slab on grade, you need to have R10 around the entire perimeter, 2 feet in depth. If you're doing a radiant slab, a heated slab, the R10 has to insulate the entire slab under the full slab. These are the basic criteria that you build to under the prescriptive appliance compliance approach. These have not changed in the new code. These have been around for quite a while. Now, we're going to get some additional credits. 406 that I've been alluding to is the additional efficiency requirements for all new construction covered by the code. This includes additions. We're not going to talk too much about additions today, but they're treated, they need the energy credits. And change of occupancy. Say you're turning an old shop into a dwelling unit or a garage. Anyway, these are all requirements that are in Section 5, which is the existing homes area, and all the requirements you'll need in Section 406. So this is where we need to get to. All right. So these are how these energy credits are factored. In small home, 3 credits. This would be 1,500 square foot of condition 4 or less. Medium, 6 credits. Large dwelling, 7 credits. Dwelling serving R2 occupancy, that is low-rise multifamily. Not townhomes, but low-rise, 3-story or less multifamily. Generally corridor loaded or individually garden style, what they call woody walk-ups. 4.5 credits. That tripled from 2015. Additions went to 1.5 credits. Less than or equal to 500 square foot. It used to be a half a credit. So there's going to be some real challenges, particularly in the medium dwelling and the R2 occupancies as well as the additions. All of the information on these energy credits needs to be clearly identified on the plans and the permits and the tools that we have to show compliance, like the prescriptive path worksheet. All right, where were we? We were at 1.5 credits for small buildings. That went up to 3. 3.5 credits went up to 6 for medium-sized buildings. Again, large buildings went from 4.5 to 7. This 5,000 square foot large dwellings. Multifamily went from 1.5 to 4.5, and additions went from 500, the small additions less than 500 square foot, like a garage ADU or something, went from 1/2 to 1.5. In addition to that, there was a proposal that was accepted, appealed, and the appeal denied, having to do with fuel normalization. This gets back to carbon emission equivalency. As I noted, the requirements in the energy code from the state legislature require improvements in energy savings to 2031. There's another metric that has entered into the realm, and that has to do with reducing our carbon footprint and looking at energy codes as a possible way to help in that reduction. This is what we're talking about. If you're building a home and heating it with a combustion device, in other words, a gas furnace, oil boiler, something like that, that uses combustion heating and fossil fuels, you will get no credits in the energy code for that. So say you're trying to meet 6 credits, you get nothing if you put a gas furnace in or a fossil fuel furnace. Doesn't ding you, but you don't get any credits. Now, if you go to system type 2, the initial system uses a heat pump. This is just a heat pump, a minimum efficiency heat pump on the market. You get a full credit, both in single family, which is called all other, or R2, which is the low-rise multi. Now, if you got into an electric resistance heat, so this would be baseboard, cadet type heaters around the house with no heat pump, you actually have to come up with another credit. You get a negative credit, both in both single and multifamily. If you put a ductless mini split in, which quite often folks do, and you do that in accordance with the requirements that would allow you to put it in the primary living area and heat the other areas with electric resistance. Instead of a heat pump in type 2, which gets you a full credit, you'd get a half a credit for that mini split serving the large area. And any other credits that don't fall into that would be a negative credit and would make it more difficult to comply with the code, both in the single family, and there's a half a credit there for R2. So the takeaway here is gas furnace, you're not going to get any credit. Heat pump, you're going to get credit. Electric resistance heat only, you're going to go backwards and have to get even more credits. So now let's talk about the energy credits in general. And I'm going to start by pointing out that this is kind of like a Chinese menu. You get so much from column 1, so much from column 2, column 3, all the way up to column 7. But you're only allowed, generally speaking, 1 from each column. So the first important area to understand is the energy envelope credits. Now, these credits have been changed from the 2015, a lot more of them. And I'm going to quickly go through what these credits are. Credit 1.1 is basically going to a better window or vertical fenestration of U.24. So if you take our glazing worksheet, which is available to help you determine what the overall fenestration U factor is, and you put in your window schedule, and you come up with an average of 0.24 or less for your fenestration, you would get a half a credit by taking option 1.1. Instead of going 2.4, say you went to a triple pane window and went something around a 0.20, you get a full credit in both single and multifamily. Now, if you wanted to combine that, say a slightly more efficient window than the minimum 0.30, say a 0.28, this is what quite typically is available in the market with the current code, and you add R8 to the floor. So instead of an R30 in the floor, you have an R38. So slightly better window, 2.8 window, R38, or if there's slab on grade, the entire slab would be insulated. If you were to do that, you would get half a credit in the single family. So basically adding R38, and this is something that is typically done now. If you were able to also use a UA trade-off calculation, which I will explain later, to show 5% reduction in overall conductive UA, you could get that credit without using these prescriptions. That is credit option 1.3, and it's very often taken, but I think with the new code, people might be looking to higher credits, such as 1.4. This is a slightly better window, a 0.25 window. It's got R21 on the wall, plus a continuous insulation of R4. That's called CI. Many builders are looking at CI now as an envelope option to improve the credits they need and also improve the moisture durability of their homes and reduce the thermal bridging associated with all the wall framing. If you were to do this with the CI and a little better window and a little bit better insulation in the floor, as well as the same thing below grade, you get a full credit. Or if you equivalently were able to reduce the UA compliance by 15%, it would afford you that credit. Now let's look at the 1.5 credit. This is really starting to get down to things that are challenging most builders. Very few of them have purchased a triple pane window, which is on the order of a 0.22. Many have not put in the single rafter or joist vaults, a combination of foam and insulation that would get a full 49. They've been at about 38. Folks do have familiarity with going to a 38 in the floor, but you're going to have to get R12 continuous insulation under the siding, and that's been very challenging for many. If you're able to do that, it gets you 2 whole credits in single family and 1.5 credits from option 1.5 in multifamily. All right. We also have some other credits that are really high efficiency, super triple pane windows, 3 inches of foam sheathing, R48 in the floor. This is 1.6. We're showing a 40% reduction in the envelope to get you 3 credits. These are kind of passive house level credits. or very energy efficient builders building with double wall construction and very innovative building systems. For those, you get 3 hull credits and you can reduce the need to put in expensive HVAC and mechanical equipment. It's all about your comfort, your familiarity, and your sub's familiarity with these options. I would encourage all builders and subcontractors to start looking at the future and deciding, is this something they want to get up to speed on now? Do I want to learn about how to build a higher R-value wall? Do I want to learn about what are the challenges of triple pane windows? Anyway, then option 1.7 is a little step back, and if you needed a half credit, you could get that half a credit by going to reasonably good windows, which are out there now, and everybody's using at about a 0.28, and go to an R49 advanced ceiling. And that would be like an oversized truss or a way of making sure you have R49 fully at the eave all the way out where it tapers. And that's a half a credit that might be afforded to folks that want to do that. Okay. Next is column 2. This is getting into what we like to call build tight, ventilate right philosophy in residential building science. It's about controlling the air leakage, building the home tighter, and then putting in effective mechanical ventilation that allows the occupants to control their indoor environment as opposed to Mother Nature. I've been working in this field for over 40 years, and the question I always get when we talk about build tight, ventilate right is, how come they make us tighten up the home and then they make us put a fan in to ventilate it? And I always answer it as, who do you want in control of the indoor environment and your indoor air quality? Mother Nature, or your tenant, or the building owner, or the occupant, the homeowner? Whoever it is, they're empowered to control their environment as opposed to Mother Nature. With Mother Nature, in the winter, typical homes are over-ventilating and wasting energy. In the summer, they're typically underventilating. In the shoulder months, many people don't open their windows for a variety of reasons, and they can also be underventilating. It also means that if there is some sort of a pollen event or some sort of event where you might not want to ventilate, you don't have control because you have a leaky home and Mother Nature's in charge. Build tight, ventilate right. The philosophy, again, is who do you want to be in control of your indoor environment? It's not without challenges. If you're going to build tight, ventilate right, you have a responsibility to let everybody know involved of what your goals are. And that includes education of the occupants and commissioning of the system, which I'll talk about later in this presentation. Anyway, let's talk about the options under option 1. Air leakage control and ventilation system effectiveness credits. If you don't want to use a heat recovery ventilator, but you think you can build the home down to about a 3 air change an hour at 50 Pascal test metric, the energy code now requires 5 air changes an hour, and that won't change. So if you have to test, and if you're any higher than 5, you better tighten it up to get your CO. If you're going to get some energy credits, you can get it down to 3 air changes an hour, or an equivalent metric for multifamily of 0.3 CFM per square foot of apartment surface area. In any event, if you build them tighter and you put in a very efficient exhaust fan, you would get a half a credit in single family and a full credit in multifamily. There's some requirements there that need to be specified on the drawing. This is non-heat recovery, build tight, ventilate right. Now, if you want to get additional credits, you can build tighter and use heat recovery ventilation. That would be 2.2. 2.2 basically says I need a 2 air change per hour, blower door test or less, or 0.25 equivalent for multifamily, and I need to put in a heat recovery ventilator with a minimum sensible heat recovery efficiency of 0.65. So the way a heat recovery ventilator works is it pulls stale, polluted air out of the home and preheats incoming fresh air with that heat in the polluted, stale air that's leaving through a heat exchanger and recovers energy. It also filters the air it's bringing in. little bit more about that later, but I would encourage folks to spend some time learning about heat recovery ventilation and blower door testing. We have a variety of videos on our website that can help. All right, so you get a half a credit if you get down to 2 ACH and put in a reasonably efficient air-to-air heat exchanger or energy recovery ventilator. If you make it tighter, if you get it down to 1.5 and put in a more efficient heat recovery ventilator, you get 1.5 to 2 credits. 2.4 suggests down to passive house levels. Really takes some experience to get here. And you get down to a 0.6 air change at 50 Pascal, tested blower door credit. Then you're able to get a high efficiency heat recovery ventilator with 80% or 0.8. You get 2 credits or 2.5 credits in multifamily. So that's the cookbook for the Build Tight, Ventilate Right option 2s. Option 3s really get into the HVAC side. So once you've figured out what you want to do on the envelope and equipment for ventilating, then let's think about what kind of HVAC system you're going to be putting in. As I noted, you won't get any credit for the gas furnace, but if you put in a condensing furnace using 3.1 high efficiency Energy Star furnace, you get that credit. Or a boiler with Energy Star boiler. Now, if you put in a central heat pump, not with a minimum efficiency, but a little bit higher than the federal minimum, with a heating seasonal performance factor of 9.5 or greater, you get an additional credit. In other words, you get that fuel credit before, plus this additional credit for going beyond the minimum heat pump efficiency. Same thing for 3.3. You get a COP on a ground source heat pump. This would typically be done in a large McMansion or larger 5,000 square foot building where you typically see these, or in some sort of district heating in the event of a commercial shared integrated system. The other way you can get a credit, and this is the way most people do that have balanced out electric resistance in the bedrooms with a primary heating system that was zonal electric, what they do is they put a mini split in the largest zone of the house, and it is able to take away a lot of the electric resistance heat from the other zones as well as the primary zone. So you have 1.5 energy credits you can get in single family for putting a mini split in the largest zone and backup electric resistance in the other zones. Or in multifamily, you get 2 whole credits for that. So those are your basic energy credits. We have some more. If you were able to put in a centrally ducted system and put in a heat pump with an HSPF of 11, this is a higher performing heat pump. You get a credit and a half for it in single family. There is no credit for it in R2 multifamily. Then if you were to go to a ductless mini split where you didn't have electric baseboard in the back bedrooms, but you had other types of efficient mini split heads, and they all had a minimum HSPF, heating seasonal performance factor of 10 or greater, you get 2 whole credits. So if you start to go to a ductless system and no electric resistance backup, you get up to 3 credits in R2 and 2 credits in single family. You'll note this little footnote A. It's important that if you are getting the credits with footnote A, applies. That means you can't be putting in any backup electric resistance heat more than a half a watt per square foot. That means a 2,000 square foot home, if you needed to put some heat into the bathrooms or some little utility closet, you'd be limited to 1,000 watts. This is something to pay attention to as you design your heat pump system serving all the zones. Distribution credits. Now, if you were to go to a ducted system, and you move all the ductwork inside the conditioned space and the air handler, you would get credit 4.2. This is the most important credit in the new energy code. We're not going to be able to move forward in the future meeting the energy code in a cost-effective way if we keep putting our air handler in the garage and we put our supply ducts in a vented crawl space and our return ducts in a hot or very cold attic. This is the way it's always done, and this is the way it can no longer be done. This is the big change in the energy code. And I'm going to talk a little bit about this. So this is the buried ducts You get a full buried duct. You don't have to test 4.2. We did provide one other option. If you move your air handler inside, you're allowed to bury some of the supply ducts up in and return ducts up in the attic, but you only get a half a credit, and you still have to do the testing of the ductwork. So this is the most cost-effective credit, 4.2, that anyone has ever had for years, and now it's going to be time that we take advantage of it. There's some hot water credits as well. Domestic hot water, there's a drain water heat recovery technology that could be used on the showers to get you half a credit. There are Energy Star rated water heaters that you definitely need to look at if you're going to be looking to comply with water heating. Gas, you'd get a half a credit for a UEF of 0.8. That's kind of entry-level tankless. If you had a UEF of 0.91, this is kind of a condensing tankless, you'd be able to get a full credit for both single-family and multifamily. Or if you put a solar hot water system in, which we have not seen a lot of. We've seen a lot of solar PV, but not a lot of solar thermal. But you could also get the credit for solar hot water. I know some of that's going on over in Eastern Washington with some innovative builders. Water heating, the way that folks are going to be moving in water heating, if they're not going gas in the future, is to heat pump water heaters. And these are virtually going to be needed if you want to come up with the sufficient energy credits in many of the cases here. You can get a heat pump water heater credit of 1.5 for a tier 1. I would encourage everyone to go to NEA's advanced water heating specifications. Just Google NEA and hot water and spend half an hour learning about this technology. This is critical technology. Along with ducts in the conditioned space, this is a technology that you most likely will need to be familiar with and embrace with the new energy code. You can even get the tier 3. Most of the products out there now are the NEA tier 3 and get 2 to 2.5 energy credits for it. If you were to go to a high efficiency split system, a heat pump water heater with a UEF of 2.9, there's a few of them in the market, you could get a 2.5 to 3 energy credits. There's also credits for renewable energy. So generally speaking, around here in western and eastern Washington, good orientated performing system will, for every kW of PV power, you might generate anywhere from 800 to 1200 kilowatt hours. If you were to put in a 6 kW system, say, or a 3 kW system here, excuse me, you could get a credit for each kW roughly. So we're talking about being able to show that you've got 1,200 kilowatt hours of generation, and for each 1,200 kilowatt hours, you get a credit up to 3. So if you put a solar system on multifamily building and appropriated it to each of the units, that might be a solution for some builders to get some of the energy credits they need. Same thing with single family. If you're going solar, consider these energy credits. There's also appliance credits. These are new. We'll talk a little bit about what they require. You get a half a credit for it in a single family and a credit and a half in multi R2. A dishwasher, Energy Star rated, that's no big deal. That's pretty much all of them out there. No real incremental cost for that. Or an Energy Star refrigerator. And you would only have to provide the refrigerator if it was being installed as part of the home. If there was no refrigerator there, then you would not need that credit. However, the big jump is the washing machine. It's an Energy Star, the big jump is the Energy Star rated dryer, which is a ventless dryer that has to have a significantly higher efficiency, a CEF of 5.2. This is a new dryer that's gaining a lot of attention in the United States. It's been used in Europe for years. This may be an option that many multifamily builders want to look at because it eliminates the need for a dryer vent or a penetration in the exterior envelope. So that's the appliance credits. Get familiar with the Energy Star appliance program and see if this meets your needs for your credits. All right, so let's talk about where the combinations are that might get you there. I'm going to give a couple examples. This is an all-electric heat pump home. It's your medium-sized home where 6 credits are required. In other words, it's somewhere between 1,500 and 5,000 square feet. First credit that we're going to get is a HSPF, centrally ducted heat pump that's serving the house. And there's no backup heat other than, say, half a watt per square foot. That's that footnote A. Then we moved all the ducts into the conditioned space because we actually sat down with this floor plan with the heating contractor ahead of time and the builder and the designer and figured this stuff out. If you don't figure it out, you'll never get this credit and you will have lost the most cost-effective option in the energy code. Let's get this credit on every new home. The code needs to transform our practice in the Northwest of moving ducts into the conditioned space and getting them out of the garage, as I said, the attic, and the crawl space. You don't buy an expensive Tesla and drive it on flat tires, nor do you buy an expensive HVAC box and run it in an unconditioned space so that only 2/3 of the heat that it generates makes it to the house. That's what 4.2 is all about. I'll talk to you a little bit more about that later and the importance of it. Then we build tight, a little tighter, get it down to 3 ACH. That's just coordinating with your sub so that they know who's going to seal the leak, where the leak is, when does that leak get sealed, what material that leak gets sealed with, and who's going to check on it. It's just basic QA, whether it's gas piping, ductwork, water piping. Your team understands their responsibility in getting the home down to 3 air changes an hour and getting the credit for a good whole house exhaust ventilation system. That gets you half a credit. Then if we put R38 in the floor, like most are already doing, or R10 under the entire slab and a little bit better window that's pretty much typical on the market, you get a half a credit. Then we go to a heat pump water heater, we get 2 credits for tier 3. And because we're using a heat pump, we get that fuel equalization credit. So that's how we get there, the 6 credits. You can see the heat pump upper left, central heat pump, ducts in the conditioned space. This was Quadrant, used open web truss system on a 2-story home. Blower door to test. Make sure you're going to pass that test. R38 and slab insulation. Good exhaust fans, triple pane windows, and a heat pump water heater down in the lower right. The way these heat pump water heaters work is they take air from the environment they're in, they cool it down with a heat pump, and they dump that heat into the hot water tank. So this is the way to get those credits with an all-electric house and a heat pump, centrally ducted. You move the ducts inside. Next one would be, say I don't want to use that heat pump water heater. They're going to run out of water. I want to have some gas water heat. Well, so now we go to a higher efficiency heat pump, get a little bit higher credit, move all the ducts inside. Don't want that Tesla on flat tires. Continue to build tight, ventilate right, put in the good windows and the floor insulation, and now go to a tankless water heater, as you'll see down in the lower right-hand side. This is vented to the outside, combustion air from the outside, no interaction with the inside, no venting issues, and you get a fuel equalization credit because you went with a heat pump, even though you had gas water heating. The fuel equalization credit only applies to the space heating. All right, so that's how you get there with a heat pump heat and gas water heating. Now, so you wanted to do gas heat. I want a gas furnace. And you might need to be putting in a heat pump water heater or coming up with some more of the innovative envelope measures. So you put in a 95% gas furnace, get a credit, move all the ducts and the air handler inside, build it tight, ventilate right. Slightly better windows. Now you're going to have to put R4CI on the walls, foam sheathing or something equivalent to get that credit. And you need to go to an appliance or something equivalent to get a half a credit. And then you get your heat pump water heater in there and get your 2 credits. So the gas heat's going to be a real challenging one. But this is one option on gas heat. Now let's talk quickly about heat pump water heaters, electric resistance, multifamily. Go with ductless heat pump with electric resistance, triple pane, heat recovery ventilator, and a tighter envelope. That would get you there. If you went with ducted cassette units or some sort of combination of mini split or multi-head heat pump that serves the entire unit, and there's no electric resistance backup, you could get the fuel equalization credit, the 3 for the heat pump, and build tight with an HRV, and you get your credits that way. You actually have a little bit extra. So let's talk about the other compliance paths. At this point, we've gone through some of the options in the prescriptive paths, and the UA alternative is something that if you have envelopes that aren't prescriptive assembly, that you can use default values to get there. The challenge with the UA alternative is that if you're building a house with more than 15% glazing, it becomes a lot harder to make it comply. The prescriptive path allows unlimited fenestration, whereas the alternative UA does not, nor does the simulated performance path. Note to architects, if you're building a house with a lot of glazing, this is going to be a challenge to you. All right, so we have a software program that does these calculations. You would go in and put the information in on the particular home and the size of the home. It will determine how many energy credits are needed, as well as what the UA that your proposed design has to come into to meet the code. So here we have a 2,300 square foot home where the target U values are based on the prescriptive path, and a target UA of 367, that's BTUs per hour per degree Fahrenheit. And you also would have to come in with 3.5 credits for the size home. The proposed design, if you look at it, has 398 is the UA, and the credits are 3. So this clearly would not comply. For 2 reasons. It doesn't have it's short on credits, it's short a half a credit, and it's short on UA. So they have to go back and make some adjustments and do more trade-offs so you could come in under the 367 and also select another energy credit. As I said, not many people use this approach. If you do and you have questions, we have a training video on it, and also call us and we can happy to help you. Simulated performance approach has the same challenges. It makes it harder to comply when the building is over 15%. And also, as I noted, we're not aware of currently any software that meets the requirements to be used. We may start to see this as energy raters start working with builders who want to meet our energy code and also want to get a tax credit this year. All right, we're going to start to talk about the other end. We're talking about the design end and what needs to be submitted at the design end in terms of compliance. At the inspection, field inspection, before a CO is given on the home, a permanent certificate shall be completed by the builder or the approved party. That needs to be posted on the wall in the space where the furnace is located, utility room, or an approved location. The certificate shall list the R value, ceilings, walls, slabs, all of that stuff, the U factors for the glazing. It needs to have the HVAC, the water heating, the appliances, the renewables, and it needs to document the testing of the ductwork leakage. Remember I noted that if you move your ductwork outside the conditioned space, you need to test the ductwork. Well, that would need to be documented. The results need to be documented on the certificate, as does the blower door test. Remember I said you need to come in at 5 ACH 50 to meet the code and get a CO, or lower if you're trying to get some energy credits. That will need to be documented with an envelope air leakage, what they call blower door test. In addition, if you're going to build tight, ventilate right, you need to commission the ventilation system and make sure that it is ventilating right. So you're going to need to document the flow rate of the system in accordance with the codes. And this is the certificate. The code official may require test documentation, including an electronic record of time, date, location of the test, using time, stamp, smartphone, photo, or air leakage testing software. I've been working the code program for almost 2 years now, and I can tell you that there's a lot of non-compliance with the blower door and the duct leakage tests. People are cheating, writing down incorrect numbers, or just writing down things that they didn't know better. What we call out and outliers or outliers. As a result, the new sticker has a requirement to provide GPS and timestamp verification so somebody can't write the same number down over and over and over. Expect building departments will start asking for, do you have documentation of these tests that you wrote down on the certificate? These tests, expect the building departments will start be asking for these certificates to be completed and signed off on. So this is really important. As I noted, here's the section on the duct leakage testing. You notice it says, do HVAC tests include GPS and timestamp verification? It also asks that for the blower door, the building leakage tests. And a whole new section on the mechanical ventilation system. Somebody's going to need to sign off that they provided the operation and maintenance instructions to the building owner. And when did they? And on what date? They have to define what the type of system is and if it was correctly labeled and specify the controls. Then they need to determine what the design flow rate for the whole house ventilation system was and determine that that is being set on site during commissioning. It also asks to turn the system up to high speed and measure the flow rate to see. Many times people will want to have a little bit more flexibility to increase the ventilation rates when more people are in the home or something's going on. So we're documenting the measured flow rate as measured for compliance with the design, and also documenting the flow rate on high speed. And then again, can you verify it? Are you an outlier or an outlier? It's really simple to take a picture of the gauge with your cell phone. And most of the automated testing equipment that Retrotech or the Energy Conservatory make, they're the folks that make the testing equipment. They all have the documentation capabilities on their reporting. This is going to be really important. This is a big change. Nobody likes change. I hear folks, the only people like change are babies with a little poop in their diapers. And that's not us. We need to embrace these certificates and these build tight, ventilate right principles, if those are the choices we're taking to meet the new energy code, and make sure that everybody is on board with this stuff. If you are the tester, you may have the duct leakage affidavits to sign and give to the builder so that the builder can fill out the certificate. We have these affidavits for new construction and existing construction on our website you can download or use your own agreements. We also have tools for the duct testing calculations if you're not going to do them with the software provided by the manufacturers, as well as the blower door calculations. So those are calculators and affidavits that are available to help the subcontractors document their work to the general. All right, so why is it that we seal ducts? We seal ducts for health and safety, comfort, energy savings, and durability. Here's an example. It likely has to do with some moisture damage from overpressurization of a home. We don't know, but we will learn. So as I said, there's a criteria in our code that all ductwork that's outside the conditioned space or buried be tested. Generally, it needs to be tested, so for every 100 square foot of conditioned floor area, you can only have 4 CFM of leakage. That means for a 1,000 square foot home, the duct test has to be under 40 if you test it rough-in. If you test before the air handler has been installed at rough-in, then it would be 3 CFM, or 1,000 square foot would have to be less than 30. If you do a total leakage test at the end of the test, it would be 40. And there's some options for the blower door and the duct blaster to be used together to measure leakage. And that last bullet, where you're also pressurizing the ducts so you're not measuring the leakage associated with the ducts inside the home, and that would be done at post-construction. Better off to try to get the ducts tight at rough-in. But if you need to, or if you failed, sometimes the leakage exterior test can help you get out of a jam. So why do we seal ducts? You know, everything's great. All joints need to be sealed. Connections shall be mechanically fastened and sealed. These have been in the International Mechanical Code for years. And unlisted duct tape is not permitted as a sealant. Duct tape is good for everything but ducts. Have you ever been up in an attic, 120, 140 degrees summer, and the duct tape's been there for 20 years, and there is not one, it's dried up and peeling up? That's what happens with duct tape. So if you're going to do some duct testing, we have a series of training classes for heating contractors to get certified so they can get their name on our list and be certified as a trained duct tester. That doesn't mean that you don't need to learn how to use this equipment. You need to learn how to use the necessary equipment from the manufacturer. But our training will teach you what the requirements are of the code and why it's important. So this is the kind of equipment you need: a duct blaster. The upper one's the tech. The lower one is the retro tech, and some masks to block off and measure pressures. As I said, duct tests are not required if the air handlers are located entirely within the building. And we do have a little exception where we allow 10 linear feet of ducts in the return and 5 on the side and supply. And you still can get this credit. As I said, buried ducts still need to be tested, though. Here's the criteria on the testing. I'm not going to go into that, but I would familiarize yourself with the code. All ducts have to be R8. Buried ducts, some other examples and some resources that you can evaluate and learn a little bit more about the importance of making sure that if you do bury a duct in the attic, that you've effectively insulated it and not disturbed the requirements for the insulation up there. All right, so let's get back to real cost-effective, keeping you from driving the Tesla on flat tires. Moves the HVAC into the conditioned space out of the crawl space, garage, or attic. It's by far the most cost-effective thing. It requires design planning between the builder, his sub, and the floor plan designer. Let's not drive a Tesla on flat tires. It's time. We have to do this if we're going to be serious about cost-effective improvements to our house and our buildings. So, why are we doing this? Why are we trying to move them inside? Well, when you do this, when you actually spend the time and go through every one of your floor plans with your HVAC person and your designer and figure out some of the tricks to getting it inside, you end up using less ductwork and smaller ductwork. And once you've done that, it's really conducive to good installation. Nobody can see a guy crawling on his butt in a crawl space with a flex duct 25 feet from the entry to the crawl space, wrapping mastic and zip tying. It's a failure point. We know this from utility programs. If you're in your house standing on a ladder, everybody can see your work. It's good QA. You have less ducts to put in, and the ducts you put in are easier to install and easier to do right and inspect. And every time you have a big old duct system with the air handler 40 feet away in a garage or an attic, and it turns on, it blows a big cold blast of cold air into the house, and then it cycles off, and then it cools down and blows another one. This is cycling. It's a comfort issue. It's an energy waste, and there's some real obvious reasons. We just need to do it. So look at the article on our website, Moving Ducts Inside, Big Builders, Scientists Find Common Grounds. You can look on it. It's called ACEEE Ducts. It's an article that we wrote many years ago working with Habitat for Humanity, Quadrant Homes, and New Tradition Homes. They, to this day, still use these practices. Here you go. So the first one was how we did it with Habitat over on the left. They basically had a 9-foot ceiling home. They dropped the ceiling to 8 foot in the hallways, made a little air handler closet in the hallways, and that is what it looked like. Right-sized the ducts, had a nice register right over the hallway door to the bedrooms. It throws the air. With today's modern homes, if anybody tells you got to bring the air handler or ductwork to the supply register all the way out underneath a window, they're living in the 1950s. You do not need to do that, but you need to understand how registers work and move air around in a building as you're right-sizing and designing these ducts. Having a good understanding of ACA Manual D, duct design, can help there. Work with your heating contractor in this stuff. They're really good. And if they don't understand it, find a heating contractor that does. So we're moving the ducts inside. Habitat can do it. Anybody can do it. They use volunteer labor. On the left, you see Quadrant. They took an air handler and put it on the second floor of their building, and they soundproof the room. They have a little jumper duct for their return, and it's condensing furnace. All their supply ducts go through the open web truss and provide the upstairs floors, bedrooms with supply floor registers, and the downstairs registers are in the ceiling. New Traditions doesn't use an open web truss, but they made a little space in their garage where their stairwell was, and they made that conditioned space. It's accessible from the garage through a door, insulated door, but it's part of the conditioned space. But they like it because when the heating contractor comes to service the house, they go into the garage. They don't have to get into the whole house. That was one of the takebacks. They also have to design perpendicular soffits, which means bringing your framer and your drywaller back in after the heating contractors put the ducts in. Anyway, it's about coordination and design. If you do this and you plan all your drawings and all your floor plans this way for the 2018 code, then you'll have provided the most cost-effective measure and provided more comfort and durability in the home. So again, here's the Habitat 1, drop the ceiling. You know, the architects have a term for this about transitional spaces. When you're in a home with a 9-foot ceiling and you walk around the home, you can't tell. The minute you drop the hallway to 8 foot, you can start telling about the difference, the transition, when you move into the 9-foot bedroom or main living area. Here's some more of the details on the quadrant design and the New Tradition design. It can be architecturally pleasing if you design the soffits in a way that adds to the architectural theme of the home. All right, so let's talk about build type, ventilate right. There are air barriers, and the Energy Code requires prescriptive air sealing of the envelope and testing of the air barrier. As I said, new construction and additions, you got to get your CO. You need to show a blow door at 5 ACH 50 or less. To get energy credits, as we showed, you're going to need to get it down to 3. If you want additional energy credits with heat recovery ventilation, you're going to need to build tight, ventilate right with a heat recovery ventilator. Air barriers and thermal barriers. Fiberglass is not an air barrier. They use it for furnace filters. Closed cell foam is. Quite often builders will use a combination of these two products to get good air barriers and thermal protection. We have some fact sheets. There's tons of information about how to get new construction down to 5 ACH or lower. As I said before, it's about planning 101. Who's made the leak? Who's going to seal it? What material are they going to use? When are they going to do it? And who's going to check? And we have some great videos that I would encourage everybody to spend some time looking at. Here's a video on why do we seal ducts and build tight, ventilate right. And another video on the invisible thief and on why ventilate. So this would be an assignment if you're home waiting for the virus to break. Spend some time on our website and look at these videos. There were some other efficiency requirements that changed in the code. I'll quickly go through those, but we're going to wrap it up here. Fireplace efficiency, there's two types of fireplaces. They're decorative fireplaces where you're going to have to show an efficiency, but there's no minimum requirement. And then there's vented gas fireplaces that are designed as heating systems, and they're going to need to have a fireplace efficiency listing of 50% or greater. So if you're putting in a fireplace and it's a heating device, the building officials would be looking for that FE rating. As we still have a requirement, there's no longer an all-electric home, resistance home. Generally speaking, for single family or townhouses, that mini split is still going to need to be installed in the main living area. But there are additional credits for it. You're getting about a half a credit more than you got last time for it. If there's any questions, I went through a whole bunch of information rather quickly here. I would encourage you to send us an email, go through the handout, and try to come up with a concise group of questions and shoot them our way, and we will try to answer them as quickly as we can. Or feel free to call us on our hotline. We try to turn calls around on the hotline 24 hours. However, these days it's been quite a bit longer than that. So we appreciate your patience. Again, thank you for your time. My name is Mike Lubliner, and I've been doing building science here for almost 40 years, and I hope that you found this valuable and useful. Feel free to contact us, and have a great day and stay healthy. Hi, my name is Mike Lubliner, and I work for the Washington.
Alrighty. Thank you so much, Michael, for providing that wonderful presentation. Now, without further ado, we'd love to go into our questions. So I'm going to go ahead and unmute Melinda and Michael. You should be able to unmute yourself as well. And we'll kind of go through all of those questions. Some were sent, some are not all visible in the chat, so I'll bring those questions to your attention. But first questions, let's bring up here.
Oh, okay. Are you ready for me, Nina?
Yes,
Hi.
sure.
Okay. Okay, it looks like in the chat we have 12 questions that I'm aware of. And the first one was, I believe California just adjusted their solar mandate. Is there a chance this code will be adjusted before official adoption?
Can you hear me? Can you hear me, Melinda? Everybody?
Yep, you sound great,
Yes,
Michael.
I can.
Yeah, so you could probably answer this better than me, Melinda. But no, I believe what we have what we have. It's in the law. It's going to be effective in November. One of the things that did drive that fuel normalization is a similar assumption to what's going on in California, and that is the assumption that future resources of electrical generation, that mix is going to be predominantly renewables. And that's kind of the assumption that drives the fuel neutrality, or excuse me, the fuel equivalency credits that we talked about in the code. So there may be some mandates for utilities that will work in unison with the assumptions in the fuel normalization credits.
Okay, great. Thank you, Michael.
I hope
the next question.
Yeah.
And in a past project, I located ductwork in a conditioned crawl space, but wasn't allowed to claim the credit for ductwork in conditioned space. Can you explain why that strategy is excluded?
The conditioned crawl space was something that people on the energy tag, some people on the energy tag, didn't believe was going to be equivalent thermally unless one put R10 down between the soil and the conditioned space. What was proposed that didn't make it through the energy code discussions was something I had proposed that would have allowed for the conditioned crawl space with an R10 under a RAT slab to be credited as equivalent and allowed to be used for conditioned space for locating the ducts. Unfortunately, that proposal did not get approved. What did get approved was that buried duct compromise in the attic. So I agree with that this is an area that we need to address in future energy codes or alternative solutions. One of the things that concerns folks about conditioning a crawl space is that it increases the surface area, it produces more contact with the earth and soil gases and moisture and other things. So if you're going to do it, you need to make sure you've really got your building science well engineered on a moisture management standpoint, ventilation. Our state isn't effectively embraced conditioned crawl spaces like a lot of other states, to be brutally honest. I hope that helps answer the question.
All right, thanks, Mike. The next one, are there adjustments to radon requirements in the 2018 IRC/Washington State Energy Code?
Nothing that I'm aware of on radon in the energy code.
Okay. All right. Next one is, if I have no ducts in the house because I use all wall-mounted heat pumps, can I take the credit for ducts in the conditioned space? I am essentially meeting the intention of that requirement, right?
That's an excellent question, and we've been trying to get some more clarification on that. If you take the credit that displaces all the electric resistance heat with heat pump units in each individual zone, and you meet that footnote A, in other words, not more than, a half a watt per square foot of backup electric resistance, then you can get that 2 credit but you can't, the 2 credit one, assume that there was no ducts to begin with. This is a little complicated, but basically the answer is you get the 2 credit one, but you couldn't take the 2 credit for distributed heat pumps that are all ductless. If you had some cassette units, there's some discussion now about whether you could get the ducts inside credit for the cassette units. So that's a good question that we're trying to flesh out, but really the intent of that last credit was that it would be, that there was no ducts to begin with, so you couldn't take any credit for it. The energy savings in effect of no ducts was assumed in the credit already. I have a complicated answer. I can go offline and follow up with that if you have more questions on that one.
Okay, great. Thank you. And I guess anyone who did submit these questions, you can always follow up with an email to us if you need more detail. Right, Mike?
Absolutely. This is just kind of see what we can get clarified now and then follow up with ones that we don't either have time for or are going to take more discussion.
Okay.
I'm good to go for another half hour if necessary.
Okay.
Let's
the next question, could the R38 in a vault be expanded on later?
Yeah, so R38 is a challenge in the vault if you're not venting that space because of moisture. You don't want moisture pressure, vapor pressure in the house building up in the house and being driven into that assembly cavity, where if it hits a cold underside of the roof decking, it could condense and cause moisture problems. That's why we have venting requirements. So if you're not going to vent, most people will use a combination of a closed cell foam sprayed under the decking to prevent moisture migration and to warm up that surface. Or they will do a build-up roof where they'll put foam sheathing on top of the roofing membrane, on top of the roof decking. And those are 2 different options within the International Residential Code for dealing with moisture management and meeting the energy criteria in the Energy Code. What you got to look at is closed cell or foam sheeting on the top, and then you have to look at the depth of the assembly cavity to make sure you're compliant. There's some really good fact sheets on this that we hope to put on our website. Building America Solutions Center and Joe Stieberg and Building Science Corporations has a wealth of information on how to do unvented assemblies like that and make sure you're maintaining moisture. The big one when you're talking about the limiting moisture into an assembly like that is the moisture gets in there through mass transfer through can lights and leaks. So if you've done a good job of limiting the penetrations into that assembly, you've done a really good job of minimizing the mass transfer of moisture up there, which is a predominant vehicle for failure in moisture in attics, is big holes. The other one is the vapor retarder, the actual material that's retarding diffusion of moisture through the drywall. It's a combination of those things and keeping and having the right numbers and making sure that the surface is warm enough so that if moisture does hit that surface, it's not cold enough that it condense. So we can go into a whole primer on how to do an unvaulted R38 or R49. I think we will need to be working with the Spray Foam Manufacturers Association and NYMA, the North American Insulation Manufacturers Association, both of whom have good details and instructional guides on how to do these kind of approaches to the cavity insulation. Long-winded. What else we got?
Okay. Thanks, Mike. How is square footage measured to determine dwelling unit size? Exterior face of stud or interior face of finish? Habitable conditioned space that is above 5 foot ceiling height.
Yeah, so I saw that one come up before. It's the exterior measurements, the gross measurements.
Okay.
Exterior, yeah.
Okay. Why does this electric resistance heat language fail to exclude the much more efficient installed infrared heating?
The assumption in the energy code is that if it's electric resistance heat, it has a COP of 1, which means for every BTU that goes in, a BTU comes out. If you have a heat pump, for every BTU that goes in, 2 BTUs come out. So it would typically have a COP of 2 or greater. So they penalize the least efficient electric resistance relative to the other more efficient electric heating options.
Okay. Okay, great. Thank you.
I want to make another point. I want to make one other point there. There is, when we do this analysis, we have to make assumptions about comfort and thermostat settings. We know in the real world that when people do radiant floor heating particularly, or radiant heating in general, and they can keep the surfaces warm and the people comfortable, that behaviorally some people will reduce their thermostat temperatures, which can result in energy savings. Unfortunately, energy codes don't really have the ability to take credit for behavioral energy savings like that. Therefore, we don't see any energy credits from its system being radiant per se, other than it may not need ductwork, and it gets some great credits for that. But you don't get credit for that comfort thing. And that's what we get a lot of questions on. So.
Okay, thank you. What if you did line 4 without any electric resistance heat?
Well, that would depend on how you do option 4. If it was no fossil fuel, then I think a legitimate case could be made that you would not be penalized for a fossil fuel normalization penalty. I'll jump off that one when I get to it. I guess we'd have to talk about what type of fuel is going to be heating the home. If it is renewable, then it wouldn't. It clearly would not need to be dinged with a climate factor.
Okay.
Still normal.
All righty. Next one. What about radiant floor fueled by gas boiler?
Good question. So a radiant floor, it's a radiant heating system, so you get 0 normalization credits, but you could still get a credit for a high efficiency boiler. There's one credit for that, and you could get another credit because all your distribution, your centrally system, it's zone heated, but it's all within the conditioned space as long as you have R10 under the entire slab. So so you could get a couple credits for that, even though you can't get the gas normalization credit.
Okay. Who makes U0.25 double glazed windows?
I don't get into manufacturers' models and Brett makes, but what I would encourage you to do is, and we're going to have this, I think on our website as a useful link, go to the NFRC, National Fenestration Rating Council Directory, and you can type in any manufacturer you want, or window model, or window type, and it will give you the tested U value of every window that was certified in the United States under the NFRC program. So it really does depend quite a bit on is it sliders, or what kind of operator types. There is some variability. How many doors are you using in that, averaging out? There's a lot of factors there, but that's it, the answer.
Okay, great. We're down to the last 2. What is the penalty if you don't hit your intended air changes with the blower door test?
That's a great question. We're thinking about a frequently asked fact sheet that we'd give to the building officials. What do we do when we fail the blower door? And there's a couple things that need to be fleshed out. Really, it's up to the local jurisdictions to make the final call. We're just in an advisory role. But we're trying to impress upon them the importance of this stuff. And I think that there's some options. Generally, the official answer is you don't get a CL until you pass the test. So if you're not trying to get build tight, ventilate right energy credits and build at 5 ACH 50, most builders can meet that. There shouldn't be a problem. If you have some fundamental problem beating 5 ACH 50, it probably has to do with the ducts and the air handler outside the conditioned space, and nobody ever told the subs they needed to caulk and seal effectively with a plan. As you start getting down to 3 or lower, there's clearly a risk that if the builder doesn't have their subs on board and have tried this stuff and are confident and they fail, they better have some mad credits left over, or think about an end game. We have been working with the Air Barrier Association of America to try to roll out some training programs for testing of air barriers, as well as the installers of air barriers, to try to help reduce the perceived risk of selecting blower door related air tightness, build tight, ventilate right credits that, and to make sure that less people fail when they try. And I think that some jurisdictions will work with you if you're a big production builder and you're working with somebody like a rater that can help you and bring your subs up to speed as you go and learn as you go. I think that there's some different interesting models. I think it's very challenging for the do-it-yourselfers on small additions. The metrics are based on air changes per hour, and there's some limitations in the testing. So I think we're going to run into some significant situations where there's failure of these tests, and it's going to be left to the jurisdiction to decide how they want to handle it. I wish I had a better answer.
Okay, and I think you actually already glanced at the final question. How do you do a blower door test on an addition?
Oh, excellent question too. So we have two options. If you're doing an addition and you want to test the existing home along with it, the requirement is that the both combined get 7 air changes an hour. If you want to isolate the addition from the house and open up the house to the outside, if there's a door and some plastic that can be put up to compartmentalize just the addition off, then you can run a blower door test on the addition alone without the rest of the house, and your target then is 5 air changes an hour.
Okay, great. And one more question came in. Where does the Sandine heat pump come in when used for both heating and hot water? I should be able to get both credits, hot water and heating, correct?
That's my understanding.
Okay.
One thing to be concerned about when you do combo systems, and is to make sure that you have adequate separation so that you're not mixing up the tank. I know some of the research that was done originally on the Sandin type CO2 units is when they were used as combo systems, you weren't getting the stratification, therefore you weren't getting the lift or the efficiency. It wasn't operating as efficiently as intended when it's in combo mode. And then also when you're using a gas combination system, sometimes it will go out of the condensing mode under certain inlet water temperatures. So these are nuances of nerdy engineers like me. Probably don't need to understand other than it does matter, but what really matters is that you have the system designed in the case of the Sandin that you can meet the design load of the building heat loss at the same time as meeting the fixture demand rate for the hot water demand without mixing up the tank too much. So there are some challenges out there. I would, having done 40 years of Rube Goldberging innovative mechanical integrated systems, I've learned to try to keep it simple, stupid in my old age.
All right, thanks, Mike. Nina, that's all the questions I see in the chat. Did you have anything else?
Yes, Michael, we have a couple more questions that I was sent privately. If you still have time, it would be great to maybe answer some of these folks' questions. And again, for those who we don't get to questions tonight, please feel free to email Michael and Melinda at the email he provided in the presentation. This question is, how is heating equipment sizing form used by jurisdictions? In 20 years, we have never received a correction or comment on it.
That's a great question. I do not think that many jurisdictions look at the heating system sizing very, very much in depth in the detail when they're doing plan review. But what they may do more often is whatever you said the size was on the plan, the field inspector may look to verify that it's the correct size. That's where the efficiency improvements are, when you size it correctly and it's not cycling. So that's where you might get caught. But I think you're absolutely right, is that I don't see that many jurisdictions are looking closely at the numbers when the design road is submitted at the design plan review stage. They're just looking to see that some document has been submitted. And that's the size of the system that was agreed to for the permit.
Great. Our next question is, can Wazoo Energy issue an illustrated guide to measuring the conditioned area and volume the way the code wants it measured?
This is a great one. This got really controversial. There was a proposal made by the Department of Commerce that was accepted that tried to standardize the volume calculation for the blower door test requirements in the code at 8.5 feet. The reason for that was they were claiming that big vaulted ceiling houses were getting away with not as tight of an envelope as those homes that were not taking advantage of the big vault. My personal feeling was I thought that this was silly and was going to confuse things, but that was appealed by a rater and rejected by the Building Code Council. So right now, when you do a calculation of volume for the blower door test, the code will require that you assume 8.5 as the ceiling height. Don't shoot the messenger.
Great. And then another question here we have for energy credits. Can you only choose one option in each category, such as 5 times efficient water heating?
Excellent question. The only time you can double dip that I'm aware of in there is for the water heating, where you could select a efficient water heating device and also select 5A, which is that gray water heat recovery device. So the answer is just under that. The only time you can double dip is for Section 5. And our worksheet will have some rules for that and clarification on it.
Great. And then another one here we have, is a heat pump still the only option for heating a residential building, even a small unit like a 800 square foot dadu, perhaps?
But, there are some options, trade-off options, but it is fairly limited. It's getting tighter with the new code. I mean, there are other options. You can go with electric resistance, but you're going to have to make that up. There's a limitation, I believe, on the size in terms of when the heat pump will. But in general, they treat an addition just like they treat a new home. And that's really important because a lot of folks are taking garages and converting them to ADUs, or in the inner city, they're taking masonry buildings and converting them to ADUs, or in the rural areas, they're taking big metal farm uninsulated or metal buildings and converting them to ADUs. And this is a shift towards trying to find affordable housing in our state. And those additions need to meet the energy code. And it's been challenging when those units are small to come up with adequate heating solutions. So we can get into the details where the exemptions are at the sizes for the ductless mini splits. I don't have that available right now, but it's pretty small. The other thing that is a value proposition that's hard to sell, and I don't know, it's certainly an important one as we look into the future and look at the climate predictions out there that are driving some of this. There's more and more growth in demand for air conditioning, even in Western Washington. So as people bite the bullet and they go from electric resistance to air conditioning, the question that I ask is there any possibility of a value proposition for your client that they want air conditioning now when they build the house to begin with? instead of waiting a couple years and waiting for the heat spells to get worse and worse, and then rushing off to get the least efficient air conditioner as a window shaker in your window of your fancy home because you didn't plan ahead with air conditioning. So it's important to challenge people on the future, even in Western Washington, whether or not you're going to need air conditioning or not. I know that you can forget to leave the windows open or forget to shut a window in an energy-efficient home and overheat that home very fast. There's a lot of internal gains and stuff. So I do think air conditioning is going to be one that will hopefully help some of the clients consider a ductless mini split or other heat pump where air conditioning could be the icing on the cake. Having said that, it's clearly a limitation in the code.
Mm-hmm.
Thank you, Michael.
Nina, I see that one more question came in. Why a maximum 3 credits for renewables?
That's a really good question. What they did not want is they wanted to try to find a balance where, that you were trying to get a balance of envelope, equipment, and renewables. If you didn't put a limit on renewables, then they were worried that people would build energy inefficient homes with inefficient equipment and just put PV on the roof. So one of the changes that I should have pointed out is in the current code, you only got a half a credit per kW of PV. In this new code, you get a full credit. And that was the result of the solar industry coming to the Building Code Council and requesting clarification and modification to that. So we did double the credits, but there's still a limitation of a maximum of 3 so that you just don't build it, so that there's some backstop of efficiency on the equipment side and the envelope side.
Great, thank you.
Thank you, Michael.
Oh,
Go ahead, Melinda. I just saw that one come in.
yeah, it looks like there's an add-on to that question. Does the code at all address the added need of filtration during future wildfire events?
So the code doesn't have anything specific, but I have been doing some interesting research on smart ventilation controls that I alluded to, and one of the concepts is that as over time, as we have more and more outdoor air quality challenges, that the consumer has to have the ability to curtail the operation of the ventilation system. And by building type ventilating right, say you have a big wildfire event or a pollen event or a freight car with toxic plume floating through the city, providing some control so that you can shelter in place and shut your ventilation system down for these kind of what we'll call extraordinary events. But there's nothing specific in the code about that. I know that there's research going on about when you use unbalanced exhaust-only systems, whether there's any filtration going on in the walls as air is being drawn into the building through building cavities. But again, this is all theoretical research right now. There is no, to answer the question, there's no requirement in the code for that stuff.
Thank you, Michael. We got one other question that just came in. What is your understanding? What is your understanding on the amount of global warming caused by the release of all the refrigerant, the huge GWP, used in the mini splits? Are they really that much better than electric resistance when this is accounted for?
I have been asking people if you get, say, carbon savings out of 1,000 mini splits, and X percentage of those mini splits fail over the life of the mini split in a way that releases all of the refrigerant into the atmosphere, how many feet have you shot in the foot? This is a good question. I don't have the answer. I do know that there are new code changes that came into effect that are limiting the refrigerant uses in insulation materials and in refrigerant types and refrigeration equipment and HVAC equipment that are happening at the national, the state, and the international level. And I do think that if we install a bunch of heat pumps and we don't do them correctly, and we do release into the atmosphere additional refrigerants, that's totally counterproductive to the objectives. And that's why it's critical that we have the skill sets out there, whether it's build, site, ventilate right, how to install a mini split, how to put CI on a wall, how to install triple pane or an air heat exchanger, that the skill set is out there, because all of these come with risk if there's a limited skill set. And I want to just thank the folks within the Eco Building Guild, because I see all as early adopters, the people that are out there breaking trail on the new innovative systems and demonstrating that it can be done, and helping to pull along some of the mainstream builders. So this is clearly going to be a challenge for passive house builders and innovative builders that have been relying on an envelope without a lot of expensive mechanical equipment like heat pumps. And it's going to be interesting to see how this market takes shape. How are we doing? Any more questions?
We have a couple more, Michael, if you are available to answer.
Absolutely.
Wonderful. One that just came in, when will the Energy Code address reducing embodied energy?
I have no idea. That's a really excellent question. And one of the challenges is of addressing embodied energy. We're talking about it right now. The chairman of our committee on 90.2 at ASHRAE, Dr. David Goldstein, has been talking about expanding our scope to look at embodied energy. But the challenge is where do you draw the boundary line around the analysis? Is it at the factory in China shipping you this stuff? Is it at the home? Is it at the state level? And so embodied energy is really going to be critical, and it's an important area that we need to look at. And I think that folks in the Eco Building Guild have been, again, early adopters leading and looking at issues. And I wish I had a better answer for you there. I know that there are different types of foam, thermoplastics, and things that have different greenhouse gas potential than others. And I think it's encouraging that folks are receptive to using materials that have lower greenhouse gas potential.
Thanks, Michael. And then another question, can the 2018 energy credits calculator be put onto the Wazoo webpage so we can play around with it and strategize projects now starting design?
Yeah, we're working really hard to get it up there. It should be up by the end soon. We were hoping to have it up at the end of this month, but very, very soon. And I want to encourage everybody. We're going to make a recipe book, and in it, we're going to have a recipe, and it's going to be an example prescriptive path, and we want others to come up with other recipes, especially innovators in the Guild. And what we want to do is, on our website, have the top 25 recipes. And not only what the prescriptive path printout looks at for a particular recipe of a certain size home or type of home with a certain type of heating system, but what does it look like when you complete the certificate for that home or any of the other information associated with it. So we really are hoping to move forward with more guidance, and we're hoping this tool is something that you guys can all play with, kick the tires, and really try to test drive for us in the next few months. So stay tuned. That should be out any day now. And we do feel that Washington is unique with this prescriptive path approach in our codes. But we do think that once you look at that option and you still have the flexibility of doing some trade-offs with your thermal envelope, that many people find it a pleasure to work with, although it may be some limit over simulation modeling. It's certainly easier for building officials to enforce and most mainstream builders to understand. But I really do believe that we need energy raters involved. Even if they're not doing energy rating, we need to teach these builders how to move the ducts in the conditioned space, and energy raters and guild members know how to do that kind of stuff. We need to teach them what their options are. Just say no to ducts or radiant benefits or trade-offs on build, site, ventilate right. These are all skill sets that these builders are going to need these skill sets. And I think that folks within the Guild have really been leaders in developing that. So I'm really hoping this is going to work. As I said, I've been doing this since 1984, and they say the definition of the insanity is doing the same thing over and over and expecting different results. I think we're making really good progress, but that doesn't mean that we are there. If this stuff was easy, we would have been there already. And as I said, you know, back in 1983, the Model Conservation Standards called out a 2 ACH 50 house with an HRV and an R25 wall. So appreciate the Guild's support and questions. These have been excellent questions. Do we have any others?
We have about 2 more.
Okay.
Here we go. There it is. So we have a question from one of the participants for some resources about efficiencies for moving air handler and or ducts into conditioned spaces to help them convince clients.
Excellent. Yes, I would start with that publication that I referenced, but we are going to be putting on some webinars with the tricks of the trade. If you're working with manufacturers of ductless VRF heat pump systems, there's a whole bunch of new opportunities of combining cassette units and individual units in zones to reduce the amount of ductwork. I'm telling you, this is not going to be as easy as people think. It's going to be virtually impossible if the builder doesn't sit down up front with the designer and the heating contractor and employ some of the tricks that we are discussed today and are going to continue to show in training. But that's where the rubber hits the road, is good load calculations, and then realizing that that the most cost-effective thing you can do is get the tires full on the Maserati.
I love that metaphor. Thank you, Michael. And last question for you. It seems 2.2 specifies as an HRV, but can we also use an ERV? I don't know if you've addressed this yet.
Yes, as long as it has the sensible efficiency. And there's some pluses and minuses of ERVs and HRVs, and I would encourage the folks to, you know, work with the manufacturers of those products to decide when it's appropriate to do an HRV or an ERV. Some of it has to do with condensate drains and which objectives you're trying to meet with the efficiencies, but what climates you're in. And yeah, I use that acronym. I don't know if it's better with a Prius, a Tesla, or a Maserati, but I don't care what the tire is, it shouldn't be flat.
Great. Well, thank you so much, Michael. That was wonderful. And thank you all so much for participating in today's events. Thank you to our Guild supporters, and of course to this, this event's main sponsor, which is Mighty Energy Solutions. So thank you all so much for everything. And if you did not have the chance to ask the question to Michael, what is that email? Just one last time so folks know as they're leaving today if any other questions pop in their mind to reach out to you and Melinda.
It's energycode@energy.wsu.edu. That's right, Melinda, right? Yeah.
Perfect.
And if you go to our website, and just click on it, you'll get an email.
Perfect. Well, thank you. And thanks again.
I have one last thing I'd say. I want to put out to a gentleman. I mentioned that I started working with the Eco Building Guild, and I haven't worked with you guys in years as much as I'd like to, but about 20 years ago, I was on the board of the Eco Building Guild. I think I was actually the president of the board for a few months. Back in the days with Dave Heslin, John Alexander, Charlie Stevens, and we were on our deathbed. We were trying to figure out how we were going to sunset the organization. And thank God we didn't. And I want to put it out to John Alexander and some of the others that have been there with the Guild, keeping it as a very important, viable entity. And it really makes me happy to see such good turnout, such good questions from a really leading organization. So thank you again for putting up with me rambling for a few hours here.
It's been our pleasure, Michael. Thank you so much. And with that, again, please feel free to check out the Eco Building Guild's website for upcoming Guild events coming this summer that are all virtual. And I hope everyone stays safe, and a huge thank you and a round of applause to Michael and Melinda. This was fantastic, chock full of very wonderful information. Thank you so much for your time today. Here at the Guild, we really appreciate it. Thank you.
Stay happy and healthy, everyone.
Thanks. Bye-bye, everyone.